Okay, thank you very much. It is a great honor, a great pleasure, actually, to be here and see the speeches, the presentations that have gone before. The topic here is how to get electronics to the masses, and I'm going to take a little bit of a practical view. Synopsys is, I work for Synopsys. Synopsys is a commercial company. So, we don't take the long, I think, very well thought through views that the government and some of the other speakers take. We take a little bit more practical view of how can we get products into people's hands. And to give you a bit about my background, I spent my 30 plus years in the industry essentially trying to build products and get them into people's hands. I started and ran a small RFID company in the 80s as a young engineer. In the 90s, I started and ran a small EDA company, which was sold to Synopsys. I've been at Synopsys now for almost 20 years and stayed because it really is a very nice, high-integrity company where you can help people. There, I started and ran for about a decade the IP business, which is going very well. So my history is trying to create products and get them in the hands of people. So here, if the question is how can we get electronics to the masses, I think, of course, we have to build the infrastructure that makes it possible. But once that happens, if we can get some money to the masses, they create a market. And once they're a market, entrepreneurs will absolutely get products to them. And I've met many very smart, capable entrepreneurs here at this conference, including Venkat, who's on the panel here. So once there is a little bit of opportunity in getting electronics to the masses, I think it's all about innovation, and India has all of the raw material necessary for that. This is actually the old, okay, well, we'll go through the older version of this presentation then. For those of you who don't know Synopsys, we're an EDA company. We're the largest, number one in EDA, number two in IP. We have about 1,300 people here in India. It's our largest site outside of North America. It's our largest user base outside of North America. I think I went through this already. So in addition, so I really have 2 points to make, and there's another version of slides that makes it a little bit better. But the first point is make sure to use the most modern tools. Once you're innovating, once you're getting products to to a new market, you can't do that with very old tools. The industry that I represent, the EDA industry, probably adds about 20,000 man-years per year of development into the tools that are created to create semiconductors and create electronics. That means if you're working on some version of tool that's 3 years old, you're 60,000 man-years behind your competition in the tools you're using. That would mean that let's say you're way behind. The second is learn to leverage standards. And I'll keep this very short here, but as we heard earlier, standards are critical. They enable interoperability. Standards boost competition. Standards boost innovation. They enable much better products. They grow markets. They reduce product development risk, and they reduce product development cost. At Synopsys, we may be the largest EDA company now, but Synopsys started out as a point tool company, making just one tool that had to interoperate with the tools made by the larger companies. And so we built a very high respect for standards, and we are, I think, the leader in demanding and requesting interoperability. You would think that we might want, a company in our position would want to lock things down, lock people into the tools and things like that, but actually that's not true at all. As a matter of fact, we give out every year what we call the Tenzing Norgay Interoperability Award. I'm sure everyone here in India knows who Tenzing Norgay is, one of the first 2 men to climb Mount Everest. We give that award to other people in our industry who we think promote interoperability, including, as you can see on the list, our own competitors. So why did EDA need standards? It's once you get into the electronics business and the EDA as a part of that, you are driven by time. So this is, I think, an interesting little chart that starts with the earliest computer practical IC-based computer made, the Apollo guidance computer back in 1962, later upgraded and used to land on the moon. Most people don't know that that computer actually crashed on the landing and was luckily able to reboot, otherwise they never would have landed. We went through a series of developments, and the performance of those computers got up by, basically based on national defense needs, up about 10,000x by 1981. And that's when I would say the modern era of computing, CMOS era, PC era, et cetera, really started, with the development of the alpha processor, et cetera, leading last year to the introduction of the Ivy Bridge. Overall, that's equaled about 100 million x improvement in performance over those 50 years. So you can imagine you're trying to keep up with a rate of change at 100 million x. You really can't sit there and chisel things out of stone. You've got to go fast. You've got to take advantage of everything out there, et cetera. It means you've got to take advantage of standards. Now, EDA is, as I say, is an industry that is riddled with standards. Very good standards, which have really helped the industry, and also very, very bad standards. Unfortunately, in innovating, you learn, and you will learn, that there are many people who try to use the standards process to hold things back. In other words, if my competitor is ahead of me, let me try to get the industry to create a standard that is not their product, therefore I'll have a chance to catch up. Really slowing down the industry, hurting the industry. And I think it's important for all of us everyone in this room, to know the difference between a good standard and a bad standard. One thing I think India needs to do is to get involved in as involved as possible in the global electronics standard making process, and be a force for good, where you're making good standards that solve real problems, that are stable, that are proven, that create a good return for the industry, that create a standards enhanced environment where everyone can do better because there's a standard. And let's all avoid standards wars. Anyone who works on EDA tools in their life knows that we've had a couple of standards wars, one on low power recently that was very, very destructive to the industry. A bad standard can be malicious and actually try to slow things down. It can just be ill-conceived and try to standardize something that it's too early, hasn't been thought through. It would give a very poor return for the industry, create a standard-constrained industry, or God forbid, create a standards war. And as we all know, standards wars stop markets. We saw that you see that in computer electronics all the time.